Lesson 5-2, page 208. Number 1, drone deliveries. Based on a Pitney Bowes survey, assume that 42% of consumers are comfortable having drones deliver their purchases. Suppose we want to find a probability that when 5 consumers are randomly selected, exactly 2 of them are comfortable with the drones. What is wrong with using the multiplication rule to find the probability of getting 2 consumers comfortable with drones, followed by 3 consumers not comfortable, as in this calculation here? 0.42 times 0.42 times 0.58 times 0.58 times 0.58 equals 0.0344. Well, that assumes, let's see, we'll call it comfortable, not. Well, is that the only way that 2 people or 2 households could receive those? It could go not comfortable, not. It could go not, comfortable, not, and many other ways. So the calculation 0.0344, that doesn't include these other ways. Number 2, notation. Assume that we want to find the probability that when 5 consumers are randomly selected, exactly 2 of them are comfortable with delivery by drones. Assume that 42% of consumers are comfortable with the drones. Identify the values of N, X, P, and Q. All right, N is the number of trials. And in this case here, it is 5. X is the desired outcome. That's one way of saying it. And in this case here, it was 2. P was is considered success, and that's 0.42. And then Q is failure, and that's a general term. It's not failure as in, well, anyway. And that's 0.58. Number 3, independent events. Based on a Pitney Bowes survey, 1,009 consumers were asked if they are comfortable with drones delivering their packages. 42% yes. Consider the probability that among 30 different consumers randomly selected from this 1,009 who were surveyed, there are at least 10 who are comfortable with drones. Given that the subjects surveyed were selected without replacement, are the 30 selections independent? Can they be treated as being independent? Can the probability be found by using the binomial probability formula? Explain. Given that the subjects surveyed were selected without replacement, are the 30 selections independent? Well, since we didn't do it with replacement, they are dependent, not independent. But if we take 30, and we divide it, how many was it? There was 1,009. All right, so let's see what that is. 30 divide 1,009. That is 0.029. So that's basically 3%. And 3% is 0.029 is less than 5%. Since it's less than 5%, we can treat it as independent. Which means we can use a binomial the binomial probability formula. All right, number 4. Seem to be having a little problem here. There it is. Number 4. Using the same survey from exercise 3, the probability of randomly selecting 30 of the 1,009 consumers and getting exactly 24 who are comfortable with drones is represented by 0 plus. And I've used this already before. What does 0 plus indicate? Well, it means it is greater than 0. Not greater than or equal to, but 0 plus is greater than 0. It could be 0 point or which are all very, very close to 0, but they are not 0. So does 0 plus indicate that it is impossible to get exactly 24 customers who are comfortable with drones? No. But it's darn near. All right. Yes. Let's try number 5. These say identifying binomial distributions. In the exercises 5 through 12, determine whether the given procedure results in a binomial distribution or a distribution that can be treated as binomial. For those that are not binomial, identify at least one requirement that is not satisfied. So number 5. Clinical trial of Y-sort. The Y-sort method of gender selection developed by the Genetics and IVF Institute was designed to increase the likelihood that a baby with a boy. When 291 couples used the Y-sort method and gave birth to 291 babies, the weights of the babies were recorded. All right, so number 5. Okay, does this result in a binomial distribution? Well, when it says baby, when 291 gave birth to 290, the weights of the babies were recorded. That doesn't have anything to do with whether it's a boy or a girl. So we're going to say that is not a binomial, distribution. And each of the weights has more than 2 possible outcomes. Each weight has more than 2 possible outcomes. Remember with binomial, 2 outcomes. Success or failure. Okay? And the way number 5 is written, you couldn't do that. Number 6, clinical trial of Y-sort. The Y-sort method of gender selection developed by the Genetics and IVF Institute was designed to increase the likelihood that a baby will be a boy. When 291 couples use the Y-sort method and give birth to 291 babies, the genders of the babies are recorded. So this is binomial. Binomial. I am writing real small this morning. And success would have been a boy, failure would have been a girl. Number 7. In a U.S. cellular survey of 500 smartphone users, subjects are asked if they find abbreviations such as LOL or BFF annoying. Each response was recorded as yes or other. So binomial, And success would have been yes, and other would have been failure. Number 8. In a U.S. cellular survey of 500 smartphone users, subjects are asked if they find abbreviations such as LOL or BFF annoying. And each response was recorded as yes, no, or not sure. That is not binomial. Not binomial. Okay? And the reason why you have success, failure for binomials only. 2 outcomes. This has 3 outcomes. All right, number 9. Surveying senators. The Senate members of the 113th Congress include 80 males and 20 females. 40 different senators are randomly selected without replacement, and the gender of each selected senator is recorded. Not binomial. Well, hold a second, Mr. Carbonell. You got male or female, so you have success or failure. But that's not the problem. Because the senators are selected without replacement, the selections are not independent. Oh. Not independent. And 40 divided by 100 would be 0.4, which is greater than 5%. Number 10. Number 10, surveying senators. 10 different senators from the 113th Congress are randomly selected without replacement, and the number of terms that they have served are recorded. Number 10 is not binomial. Why? Again, 10 divided by 100 would be 10%, so it is not independent. And there might be another reason too. You have more than 2 outcomes. Number 11, credit card survey. In an AARP bulletin survey, 1,019 different adults were randomly selected without replacement. Respondents were asked if they have 1 or more credit cards, and the responses were recorded as yes or no. 11 would be binomial. And even though they're not independent, they can be treated as being independent by applying the 5% guideline. The sample size of 1,019 is not more than 5% of the U.S. population. Number 12, I'd like for you to do and record on the form. Record on the form. So number 12 is yours. 13. In exercises in 13 and 14, answer the questions designed to help understand the rationale for the binomial probability formula. So number 13, guessing answers. Standard tests such as the SAT, ACT, or medical college admission test typically use multiple choice questions, each with 5 possible answers, A, B, C, D, and E, one of which is correct. Assume that you can guess the answers to the first 3 questions. So 13A. Use the multiplication rule to find the probability that the first 2 guesses are wrong and the third is correct. Okay, so what do we got here? Incorrect answer, I'm going to put I. That would be 4 over 5. And then we have another incorrect answer. That would be 4 over 5. And then the correct answer would be 1 over 5. If we multiply these 4 times, what do we get here? Times and then 1 wouldn't you know it? 0.128. Zero point 128. So the probability of incorrect would be 0.128. Oh, they used WWC. I should have finished reading that. Make it W, so we can follow along with the book. B. Beginning with WWC, make a complete list of all the different possible arrangements with wrong answers. So if we got WWC, we could have WCW, we could have CWW. And for each of those, we have 0.128. And for each of those, and then find the problem. Okay, so we did that. C. Based on the preceding results, what is the probability of getting one correct answer when 3 guesses are made? So the probability of 1 correct with 3 would be 0.128 plus 0.128 plus 0.128. I'm going to do my calculator. 0.384. Cool. Number 14. Number 14. Let me look at that real quick. Based on the data from a Harrison, 40% say they get 4 random leaders. All right. So number 14, y'all get to do. All right. Moving right along. Number 15. Number 15. What do we got here? It says in exercises 15 to 20, assume that random guesses are made for 8 multiple choice questions on an SAT test so that there are n equals 8 trials. Each with a probability of success correct given by 0.2. Find the indicated probability for the number of correct answers. So we got number 15. N is 8 and P is 0.2, and that's for correct. Now, I probably need to make sure you got a couple, and you might want to put these on your 3x5 card. The mean is N times P, and the standard deviation, sigma, is the square root of N times P times Q. All right. So number 15, find the probability that the number of correct answers is exactly 7. Find the probability. So probability 7 correct. Now, there's a couple ways. We can do this by hand or we can use a calculator. To do it by hand, we would have to figure out how many different ways you could get 7 correct answers. Okay, and you're going to find out it's a bunch. Okay, because think about it, you got correct, 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 1, 2, 3, 4, 5, 6, 7, and then wrong. And then you got correct, 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 4, 5, 1, 2, 3, 4, 5, wrong, correct. And then you got correct, correct, 3, 4, wrong, correct, correct, 4, 5, 6, 7. And then correct, 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 wrong, correct, correct, correct. And then correct, correct, wrong, correct, 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 2, 4. There's 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 3, 4, 5, 6, 7, 8. And then so on. Okay? And you see how that's going there? And then you got correct, correct. That's 3, 4, 5, 6, 7, 8. And then wrong. How many different ways? 1, 2, 3, 4, 5, 6, 7, 8. That's 8 ways. Okay? Now, you would have to calculate it for each one. And let's see. So let's just try it with our calculator. We're going to go to our calculator and we're going to say menu 6, 5, and then we're going to go to B, binomial CDF. Number of trials is 8. Probability of correct is 0.2. Our lower bound is we're doing, pardon me, menu 6, 5, and then A, 8, 0.2, and then we're just going to put 7 in there. And that's 0.123, 'And you would probably do that as that right there. Okay. And just to show you, let's see, one correct would be 0.2 times and then 0.8. 1, 2, 3, 4, 5, 6, 7, 8, and we would multiply all those up, and then we would multiply that 8 times, and it would give you the same answer. Okay. So number 16. Find the probability, if you had to do it by hand. 16. Find the probability that the number X of correct answers is at least 4. So this is going to be the probability that R is less than or equal to 4. That's a little bit different, okay? Because that could be 4. That could be the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. It would be all of those. All right. This one here, we did menu 6, 5, A. This one here, we're going to do menu 6, 5, B. All right. Menu 6, 5, B. Number of trials, 8. Probability of success is 0.2. Our lower bound is 0. Our upper bound is 4. We get 0.9. Find the probability. It's at least 4. Oh, at least 4. R is greater than or equal to 4, which is the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8. So let's do this again. Menu 6, 5, B. Number of trials is 8. 0.2, 4, 8.0563. Okay, here we go. Number 17. Number 17. Find the probability the number X of correct answer is fewer than 3. So that's going to be the probability that R is less than 3, which is the probability of 0 plus the probability of 1 plus the probability of 2, but does not include 3. So let's go to our calculator. Menu 6, 5, B. Number of trials is 8, 0.2, 0, 2. And we got 0.7969, so almost 0.797. All right, we'll go 3 on that one. 18. 18. Find the probability the number X of correct guesses is no more than 2. Is no more than 2. So here we got the probability that R is no more than 2. That's less than or equal to 2, which is really the same thing as this right here. 2, and again we got 0.797. Number 19. Find the probability of no correct answers. So that's going to be the probability of Florida. And we'll go in here and we'll say menu 6, 5, A, 8, 0.2, and we're going to put in 0. 0.1677. We'll just put in 0.168. Number 20, I would like for you to do and record on the form, okay? When you do the form. 21. In exercises 21 through 24, assume that when adults with smartphones are randomly selected, 54% use them in meetings or classes. That's a low probability in classes. I'm sorry. If 8 adult smartphone users are randomly selected, find the probability that exactly 6 of them use their smartphones in meetings or classes. So we're looking for just the probability of 6, right? Now, what is N? N is 8. What is P? It is 0.54. So Q, which is 1 minus P, is 0.46. All right. Now that we got that, we can go here and we go menu 6, 5. Since we're only looking for the 1, we'll do A. And number of trials is 8. 0.54. And we were looking for 6. Let's put a 6 in there. And we got 0.147. 0.147. 22. If 20 adult smartphone users are randomly selected, find the probability that exactly 15 of them use their smartphones in meetings or classes. So how does that change? Well, now we're looking for the probability of 15, right? And now we have n equals 20. So let's go. Menu 6.5a. Number of trials is 20. Probability of success is 0.54. And 15. We're looking for exactly 15. And we got 0.0309. 0.0309. 23. If 10 adult smartphone users are randomly selected, find the probability that at least 8 of them use it. So 23, we're going to let y'all do 23 and 24. See, check and see how well we're doing here. Make sure everybody's getting this. All right, let's drop down to 23, 24. Let's do number 25 here. Whitus versus Georgia. In the classic legal case of Whitus versus Georgia, a jury pool of 90 people was supposed to be randomly selected from a population in which 27% were minorities. Among the 90 people selected, 7 were minorities. Find the probability of getting 7 or fewer minorities if the jury pool was randomly selected. Is the result of 7 minorities significantly low? What does the result suggest about the jury selection process? So 25. So we want to find the probability of getting 7 or fewer, okay? And then we got N is what? Well, we got 90. P is 0.27. So Q is 0.73. Let's go to our calculator. Menu 6.5b. Number of trials, N is 90. Probability of success, 0.27. 0 to 7 is 0.000234, 5 zeros in a 5. 0.12345. Okay. Find the probability of getting 7 or fewer minorities if the jury pool was randomly selected. Is the result of 7 minorities significantly low? So the result of 7 minorities is significantly low. It is significantly low. So according to this right here, remember, if this is less than or equal to 0.05, that's our cutoff. Okay, that's our cutoff. And it is. So it would be highly unlikely to get 7 or fewer minorities. So what does this result suggest about the what does the result suggest about the jury selection process? It suggests the process was not random. Okay. It suggests it was not random. 26. Vision correction. A survey sponsored by the Vision Council showed that 79% of adults need correction, eyeglasses, contacts, surgery, etc., for their eyesight. If 20 adults are randomly selected, find the probability that at least 19 of them need correction for their eyesight. So we're looking for the probability that R is greater than or equal to 19. If 19 is a significantly high number of adults is 19 a significantly high number of adults requiring eyesight correction? So what is N? What is N? Is 20. What is P? 0.79. So Q is 0.21. So let's go to our calculator. Menu 6, 5, B, 20, 0.79 for P, and we're looking for 19 to 20. 0.566, so I'm going to say 0.05. Why? My eraser's not working. .057. So no, and that's because that was greater than or equal to 0.05. Okay, it was greater than. .27. See you later. Based on a Harris Interactive poll, 20% of adults believe in reincarnation. Assume that 6 adults are randomly selected. Find the indicated probability. A. So we got P equals 0.2. So that means Q equals 0.8. Assume that, so N equals 6. 27A. What is the probability that exactly 5 of the selected adults believe? So the probability of 5. And that's going to be menu 6, 5A. We got 6. And what was it? 0.2 for P and 5. 0.00154, 0.00154. 27B. What is the probability that all of the selected adults believe in reincarnation? So that would be 6. Menu 6, 5A, 6, 0.2, 0. I don't know why I'm doing that. 6. All of them. And we got 2, 3, 4. Probability of 6 is 0.1234. And then what was it? 64. And that 4 is probably rounded. All right, good. C. What is the probability that at least 5 of the selected adults believe in reincarnation? So what is the probability that R is greater than or equal to 5? That's going to be those two added together. So we got 0.12, and then, yeah, let's just do it this way. It's easier. Menu 6, 5, B, 6, 0.2, 5, 6, 0.0016. All right. D. If 6 adults are randomly selected, is 5 a significantly high number who believe in reincarnation? I'd say yes. 0.1, that is, remember we got 0, we got 1, that's on the probability scale. Remember, this is not going to happen. This is going to happen. And our mark is over here at 0.05. So anything in here is highly unlikely. And anything in here is possible. Very possible. Okay? That's the way to think about it. 28. Too young to tat. Let's see what we got here. Too young to tat. Based on a Harris poll among adults who regret getting tattoos, 20% say they were too young when they got their tattoos. Something to think about. I'm not judging. Number 28 will be y'all's. We'll let y'all do that on your thing and on the form and turn that in so we can see what check comprehension. So I don't know what in the world has happened to my eraser, why it has gone away. I must not be doing it just right. Maybe I'm not holding. So 28 is y'all's. 29. In exercises 29 and 30, assume that different groups of couples use the XORT method of gender selection and each couple gives birth to one baby. The XORT method is designed to increase the likelihood that a baby will be a girl. But assume that that method has no effect. So the probability of a girl is 0.5. All right, gender selection. Assume that the groups consist of 36 couples. So we got N equals 36. Okay. Find the mean and standard deviation for the number of girls in groups of 36 births. So A, what is our mean going to be? Well, that's going to be mu equals N times P, which is 36 times 0.5. What did I put 38? 36. Boy, that's 36 times 0.5. Let's see here. Let me use my calculator real quick. I get 18. And sigma is the square root of 36 times 0.5 times 0.5. And I'm going to use my calculator there. The square root 36 times 0.5 times 0.5. And I get 3. And that sounds right. 30, that would be 18 times 0.5 would be 9. The square root of 9 is 3. B. Use the range rule of thumb to find the value separating results that are significantly low or significantly high. So let me do one across here. And we'll do one across here. And then we got here and here. Oh, I wish I'd been a little bit further over, but you got it. So this is our mean, which is 18. And and our other one right here. And this remember, it was mu plus 2 sigma, which is 18 plus 2 times 3. At 6, 18, that's going to be 24. And this is over here is mu minus 2 sigma, which is 18 minus 2 times 3, which I believe is 12. Okay. So over here is, this area here is not significant. And low significance. Significantly low. And this over here is significantly high. All right. And then let's go to number C. Is a result of 26 girls, is a result of 26 girls a result that is significantly high? 26? Well, 26 would fall over here. That would be in there, 26. So I'm going to say yes. And that's because the result of 26 is greater than 24. And that would suggest that the XORT would XORT method is effective. All right. And then let's see, number 30. Number 30. Y'all can do number 30 on your own and put it on the form. 31. Significance with range rule of thumb. In exercises 31 and 32, assume that the hybridization experiments are conducted with peas having the property that for offspring there is a 0.75 probability that a pea has green pods, as in one of Mendel's famous experiments. 31, hybrids. Number 31, assume that offspring peas are randomly selected in groups of 10. All right, so A, find the mean and standard deviation for the number of peas with green pods in groups of 10. So mu equals 10 times 0.75, and that should equal 7.5. The standard deviation is going to be the square root of 10 times 0.75 times 0.25. We're going to go with 1.4 since these were 1.4. We're going one decimal place on that. B, Use the range rule of thumb to find the value separating results that are significantly low or significantly high. So our mean is here in the middle at 7.5. And then we're going to have one here, and we're going to have one there. And let's see, we got 7.5 plus 2 times 1.4 plus 2 times 1.4, that's going to be 10.5. And then 7.5 minus 2 times 1.4 is 4.5. 4.5. Does that not seem, that doesn't seem right. That's 3. That's because I got 1.5 there. Well, no, I'm supposed to have 1.4. $10.3, and that's going to be 4.7. $10.3, and that's going to be 4.7. All right, that fixes that. And then C is the result of 9 P's with green pause a result that is significantly high? Well, 9 is going to be here. That's going to be 9. We'll say it's right about there. No, it is not. 9 P's, 9 green pod P's is less than 10.3, so it's not significantly high. And it's greater than 4.7, so it's not significantly low either, so it's in the not significant area. And then 32 y'all can do. 32 y'all can do on yours. Show comprehension. Composite sampling. In exercises 33 and 34 involve the method of composite sampling, whereby a medical testing laboratory saves time and money by combining blood samples for tests so that only one test is conducted for several people. A combined sample test positive of at least one person has the disease. If a combined sample test positive, then individual blood tests are used to identify the individual with the disease or disorder. That's kind of a way they save some money. So number 33. All right. HIV. It is estimated that worldwide, 1% of those aged 15 to 49 are infected with the human immunodeficiency virus. In tests for HIV, blood samples from 36 people are combined. What is the probability that the combined sample tests positive for HIV? Is it unlikely for such a combined test to, is it unlikely for such a combined sample to test positive? What is the probability that the combined sample tests positive for HIV? So that's going to be probability that R is greater than or equal to 1, right? And right, so let's go here to our calculator. And menu 65B, number of trials, well, there's 36 in there. Well, what is P? And let's see, 1%. So we got 0.01. That's testing positive. Lower bound is 1. Upper bound is 36. And we got 0.3035. 0.3035. So is it unlikely for such a combined sample to test positive? I would say no. All right. Number 34, anemia. Y'all do number 34. It's very similar and it will show comprehension. 35. Aspirin. In exercises 35 and 36 involve the method of acceptance sampling, whereby a shipment of a large number of items is accepted based on test results from a sample of items. So number 35, the Medicis pharmaceutical company receives large shipments of aspirin tablets and uses this acceptance sampling plan. Randomly select and test 40 tablets. Then accept the whole batch if there is only one or none that does not meet the required specification. So we're looking for a probability that R is less than or equal to 1. If one shipment of 5,000 aspirins actually has a 0 or a 3% defective rate, what is the probability that this whole shipment will be accepted? So what is N? What is N? 5,000? What is P? 0.03. What is the probability the whole shipment will? Well, let's see. Menu 65B. Number of trials, 5,000. That's too many zeros. Probability of success was 0.03. Lower bound was 0, upper bound was 1. What did we do here? Oh, N is 40. Menu 65B. Number of trials is 40. 0.011. The Medicis pharmaceutical receives large shipments of aspirin tablets and uses this acceptor. Randomly select and test 40 tablets, then accept the whole batch if there is only one or none that does not require. If one shipment of 5,000 actually has a 3% rate of defects, what is the probability the whole shipment will be accepted? Will almost all such shipments be accepted, or will many be rejected? Okay, the probability 40, and I got 0.01, so it's menu 65B 40. The rate is 0.03, 0 and 1, 0.662. So 0.662. That's 40. N is 40, and that's 0.03. Little problems there. So what does that say? That says that 2/3 of the shipments will be accepted. 2/3 will be accepted, and 1/3 will be rejected. So perhaps the company is going to want to improve their quality, or they're going to be getting 1/3 of their shipments back. Number 36 is yours, and number 37 is yours. Okay? And then thank you very much, and have a nice day.